Hello guys, in this video we are going to discuss the topic of coupled systems and phase for trace. Coupled systems, we are using coupled systems to find exact solution of linear systems, for example, or general solution of a equation, differential equation. So we're gonna solve by this system, by this method, we will solve differential equations and we're gonna find general solution. To use this system, we need two things. Coupled system, we need two things. We need our lambdas, which is eigenvalues, and we need our eigenvectors. You already know how to find these ones from the other topic, matrices and vectors. So if we know these two things, we're gonna find general solution. But don't forget, if you have a differential equation like that, right, derivatives, we can write this one as ax by cx dy, and we can change this one to a matrix format. For example, x, by the way, this x prime means derivative of x, which is this one, and this means derivative of y, and we can write this coefficient matrix, right? A, C, B, D. This is the coefficient matrix of this one. Then we can multiply this one by x, y. Okay, and this is our differential equation, x and y. This means derivative, right? Derivative equation. And so this is our rule. This rule is given in the formula booklet. You don't have to memorize it. If so, our M is coefficient matrix, okay, and these are eigenvalues, and P1 and P2 are eigenvectors. So these are eigenvectors, and these are eigenvalues. Okay, and what is A and B? A and B are just coefficients, so you will just keep them as A and B. You will not touch them. Okay, so, and this is our general solution. So let's see how we can do that. Find the general solution of the coupled differential equations. Okay, how we can do that? First of all, we need eigenvectors and eigenvalues, right? How we can find that? Remember, first of all, write the coefficient matrix, right? 1, 2, 2, 1, and the determinant of this one, and you need to subtract lambda from the corners, from the left up and right bottom part, right? This is how you find eigenvalues. Equals to 0. So what it means? This times this minus this times this equals to 0, right? So 1 minus lambda squared minus 2 times 2 equals to 4 equals to 0. So 1 minus lambda squared equals to, let me see somewhere here, yeah, equals to 4. Okay, then you can sketch the graph of this one, but to find lambda, but 1 minus lambda equals to 2, or 1 minus lambda equals to minus 2, and lambda equals to minus 1, and lambda equals to 3. So this is our eigenvalues, lambda 1, lambda 2, right? Now we need eigenvectors. Remember the formula of this one, how we find eigenvectors. And we can go to previous section to see the formula. But to find eigenvectors, let me remind you the formula from the previous thing. Eigenvectors, 1 second, it should be eigenvectors formula. Let me show you quickly. This is our formula, right? M is the coefficient matrix, V is the eigenvector, lambda is the eigenvalue, and this is the thing, right? So let's copy this thing and take it. Okay. So you just need to use this formula basically to find eigenvectors, right? Okay. Okay, I'm just gonna clean this part to write it down. Okay. So M is our coefficient matrix. Let's write the M. 1, 2, 2, 1. And our eigenvalue, we don't know. Let's say V1. Eigenvector, we don't know. Lambda is our eigenvalue. Let's say it is 4 minus 1. So we found minus 1 and 3, right? And here V, which is our eigenvector. Instead of eigenvector, I'm going to write x and y, okay? So let's define our eigenvector x and y equals to this, right? Now, you need to multiply this one and find the eigenvector, right? How you can find multiply? So, first row, first column, right? 1x plus 2y equals to minus x. Okay. Then 2x plus y. Remember the second row, second column, right? Two x plus y equals to minus y. So from this equation, what I can find that if this one goes here, they should be same equation all the time, but let's rearrange the equations. And 1 second, let me check something here. 2x equals to minus 2y. Yes, from here. Okay. Then their coefficient is eigenvector, right? Their coefficient is eigenvector. So you can say just these coefficients, minus 2, 2. It doesn't matter, okay? But let's divide it by 2, 1, minus 1. So this is our eigenvector, okay? It can be the other way around, minus 1, 1. This is also correct, okay? No worries. So this is V1. With the same thing, you should write how we can find the other eigenvector. The same method, okay? Write the coefficient matrix 1, 2, 2, 1. Your eigenvector, you don't know it yet. Your eigenvalue, in this case 3, xy, okay? Then first row, first column, x plus 2y. Okay. You always find same equation here, okay? This equation is the same all the time. Okay. Then 2x, second, this one, 2x plus y. 3y. So 1x is gone here. 2x equals to 2y. X equals to y. This is gonna be the same, okay? So 2y here. 2x equals 2y. Always you will have two equations the same. And the coefficient is eigenvectors, right? So eigenvector here is 1, 1. So this is our second eigenvector. Now, how can I write, let me show you this one. How can I write the general solution, right? Look at, so I know eigenvectors and I know eigenvalues. So I'm gonna write general solution by looking at the formula here. General solution xy equals to a e to the power of lambda 1 is our eigenvector times t, okay, times p1, associated eigenvector, right? What is the -1 associated eigenvector in our case? -1, and vector is 1 minus 1. Plus b is the coefficient. E to the power of eigenvector 2 is 3 t times associated eigenvector, which is 1 1, right? Times, okay guys, this is our solution. Maybe I can delete this one. A times E, and this is the general solution of our system. Let's look at different question. Okay, phase for trace. Phase for trace is giving us an idea of how the solution curves of a differential equation changes. Okay, so for this one we need eigenvalues. For example, this is the solution curves of the, remember, differential equations does not have one solution, it has a solution curves, okay, like this ones. So it gives us how to find the solution curves. Okay, now these are just definitions, but this is summarized here. This information is summarized here, so let's look at there directly. First of all, if your eigenvalues, both of them, is bigger than 0, your phase fault rate should start from the origin. In this case, origin is called node. Okay, this origin is called equilibrium point. Okay, equilibrium point. If both eigenvalues are bigger than 0, your phase fault rate starts from origin and they go out. Okay, they go out this direction. The shape is not important. You just sketch phase fault rate that is going out from the thing. You should sketch something, 2 lines like that. Okay, this is our phase fault rate. If both of them is bigger than 0, starts from here and goes out. If both of them are smaller than 0, what is happening? They are coming towards the origin. Okay, this is how you need to sketch, and this is called unstable node. Okay, unstable node, and this is called stable node because they are coming to the origin. Unstable means they are, imagine these are forces, okay, taking origin point to the different points, so origin will move. Okay, therefore it's unstable, but everything is coming to the origin is stable, and lambdas, which are eigenvalues, they are smaller than 0, both of them. If one of them smaller than 0, one of them bigger than 0, what's the case? They do not touch the origin, they just go like that. Okay, and this is called saddle point, which is again unstable. So you should memorize, or you should remember these definitions, but depending on your eigenvectors, you should sketch something like that. Okay, So when sketching phase 4, it is enough to show 4 trajectories. In this case, for saddle point, you should start by drawing eigenvectors showing as red lines. Eigenvectors, for example, in this case, for example, your eigenvector is 1, 1. This is x equals to y line, right? X equals to y line is this one. Okay. And so the first one is x, second one is y, x equals to y, and this is line. So you should sketch this one, this line, then the other one, x equals to -1. Okay. Then these are the points, these are the trajectories. Find the eigenvalues of the matrix. Okay, the same method of finding eigenvalues. 5 minus lambda minus 2, 1, 2, right? 2 minus lambda. So how you can find, let's find it. 5 minus lambda times 2 minus lambda minus 2. Okay, so and from this equation equals to 0, you can sketch this graph and find lambdas, or just distribute this one and find lambdas, right? And lambdas are 3 and 4. Okay, so I'm gonna just skip this process a bit faster because you know how to find eigenvectors, eigenvalues. So both of them are bigger than 0. So how it should be? If it's bigger than 0, it is they are going out from the origin. Okay, or you can sketch like that, doesn't matter. And this is unstable, right? Unstable node. Okay, this is how you sketch. Sometimes, guys, eigenvalues are complex numbers. For example, like this. A plus bi. This is our eigenvalue. Okay. So what we need to do, the equilibrium point, which is the origin point here, it's called focus. But we have some rules again. If your eigenvalues are like that, you should only look at the real part of it. Real part, okay, which is this one. So if the real part is bigger than 0, it starts from origin and goes out. So 2 trajectories, it goes out. If this is the case. And it's called unstable again. If they are going from out, it is unstable. If the real part is smaller than 0, they are going in and it's called stable. They are coming towards the origin. Okay, so 2 trajectories will be enough for us. They are coming this way. Okay, if there is no real part, it's turning around the origin, the focus, we say. Okay, it's called neutral focus. You can determine in which direction the solution curves spiral, clockwise or anti-clockwise, by finding dy dx dt. This is the rule. Direction which is this way or the other way around, right? How we can find this direction? By finding the derivative of dx dt at the point 0, 1. Okay, if derivative is bigger than 0, it is 1 second, let me see, it's clockwise. Yeah, if the derivative in that point is smaller than 0, anti-clockwise. This is our case. Sketch the phase portrait of the system of differential equation. Guys, what you need to do, just to sketch phase portrait, you just need lambda 1 and lambda 2, which is your eigenvectors, right? Okay. Now, how you can find eigenvectors? Again, the same rule, right? Coefficient matrix. Okay. Then the determinant of this one equals to 0. So this times this. I mean, after this times this minus 8, you have an equation of this one, right? You're gonna get the equation of this. Then how we can find the roots, guys? How we can find lambdas here from this point, lambda? How we can find? You're gonna use the formula of what was this formula called? X equal to minus b minus discriminant formula, right? B squared minus 4ac divided by 2a. Okay, so let's apply this formula here. So minus b, which is what? Minus 2 minus or plus, right? This is the rule. Minus or plus 2 roots. B squared minus 4ac. 4 b squared 4, right? 2 squared 4 minus 4 times 1 times this one. Okay, so b squared minus 4 times 8 times c divided by 2 times 1, 2a, 2 times 1, right? Which is 2. So minus 2 minus plus minus. So 4 minus 20 minus 16, right? Divide by 2. So guys, this one is 4i, right? Because this one goes as 4 and minus, since there's a minus, we should write I. So this is 4i minus 2 plus minus 4i divided by 2, and this is the x lambdas. If you divide by 2, it's going to be minus 1 plus minus 2i over 2. So what is the real part, guys? These are the solutions. So 2 is gone. What is the real part? Real part is minus 1, as you see here, right? It is smaller than 0. So it is stable. How do you sketch the phase portrait of this one? This is the focus in our case. And they are coming towards to the origin, right? But they are coming this way, or they are coming the other way around. They are coming this way. How we can understand this one? So we need to sketch, we need to find dx dt at the point of 0, 1. Okay, what is dx dt? Derivative of x, right? This one, derivative. So instead of x, put 0. Instead of y, put 1. Instead of 0, I'm gonna put, instead of x, I'm gonna put 0. So this is 0, y 4. So derivative is 4, bigger than 1, right? So it is clockwise. So our trajectories will go like clockwise direction. This is the first trajectory. Second trajectory, you can sketch it like that. Okay, so this is the our phase portrait. Our solution curves will look like this. Okay. Okay, now the topic is phase for trace. Let's look at the phase for trace, guys. With technology, how we can do it by GDC. Okay, you should know Euler's method. If you don't know, please go and watch the video for the Euler's method. Okay, and so this is our differential equation. Initial condition is given, so we're gonna use Euler method, right? Use Euler's method with a step length of 0.5, 0.1. So this is our h. Remember, step length is h. Okay. Graph x against t. T is between 0 and 20. Okay. First of all, guys, what we need to do, we need to define this differential equations to our calculator. So instead of this is the derivative of x, right? So I'm gonna write x prime. I'm gonna say xp, x prime derivative of x. I'm gonna define this thing in my calculator as x, and this function is consists of x and y, right? Not only x. And I'm gonna define this one as in my calculator to x minus 3y, and yp, I'm gonna define this one xy, which is 2x plus 2y. I need to define those functions, and also I need to define h. Okay, how are we gonna do that? First of all, you should go to calculate, right? Then x prime, xp, they consist of x and y, so you should write x comma y. Then control and this button here, and it will be x minus 3y, right? So let's write x minus 3y and enter. It should be written down here. Now our first function is defined. Second function is y prime, yp, p, x and y, x comma y, control this one, it is 2x plus 2y. It's done. I need to define also h. So h, control this button, 0.1. Yeah, it's 0.1. If I click h, it's gonna be 0.1. Okay, it's saved. Now I should go to sheets. You remember the Euler's method? Okay, let's say this is x, this is y, because we have three variables, and this is t, right? And what is our initial condition? Initial condition is given here, x equals to 1, y equals to 0, and t equals to 0, right? This is our initial condition. Now, what is the next one? Next, x plus 1, x n plus 1, the next term. Initial value of x plus h times our function x prime, right? What is the x? Why should I write x and y? I should write initial values of this one, right? So I should write initial values of x. What is our initial value here? It is, one second. I should write initial values. Instead of initial values, I need to write the column names, okay? For example, here, let's write the function equals to, okay? This is Euler formula, by the way. This is Euler's formula, okay? Just check the formula booklet. It's given also here, right? So, first of all, initial value of x. What is the initial value of x? Is this cell, right? I need to write the cell name. Official cell name is A1. So I'm gonna write A1. Now plus h times x prime, our function, xp brackets. What is our initial case? X, instead of x, I should write A1 cell, right? A1, comma. Instead of here, I should write, instead of y, I should write B1 initial cell. And close the brackets. And this is my thing, right? Now, instead of y, what should I do? The same formula, equals to, but this is y function right now. So initial y value, which is B1 cell, right? Plus our h times our function initial value. Our function is y prime this time. Yp brackets x and y value, right? A1 B1, comma B1, right? Enter. This is our value. Then t, remember the t is always this, remember this formula here, initial t plus h. This is, please check Euler's method for these formulas, or check the formula booklet, okay? Euler's method. Okay, here I'm gonna write equals to, what is that? It's gonna be initial t, which is C1 plus h. Okay, so this is my values. Now I need to fill this table and to sketch the graph, right? Because I'm gonna fill this table, and I will go to T and sketch the graph. Okay, first of all, I'm gonna sketch this one, data, menu. I need to fill this table, data, and fill. I'm gonna go down a bit. Okay, then and enter. Doesn't fill because I need y values also, right? So menu, data, fill, and go down until the same part. Okay, y values, x values. Also, let's fill this one, t, menu, data, fill, all up to same point, go up to same point. Oh, okay, I need to find the same point here. Enter. Are they in the same point right now? Okay, here, menu. So in the question it says sketch between 0 and 20, right? T. So it means that I should go to 20 in T. I should go to 20 here, right? So menu, data, fill. So I should go a bit way down, I think. Let's go like that. If I go enter. Yeah, almost, right? Then the same thing here, or same y value, menu, data, fill. So I should go down, 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 up to 20. Because it doesn't fit, because I also need y value, x values, menu, data, fill. Okay, go down. It doesn't feel right. I mean, it takes time a bit, but the idea, menu, data, fill, it sometimes gives error, and enter. Okay, we have some data here. I can delete these ones. I think I'm not gonna go to 20. This is a bit high, so it will be like a bit similar, like small values. So, but how you sketch the graph? After filling this table, go to data, and here I want x against t. So I'm gonna put t here. I'm gonna put x here, and this is how my solution curves look like. Okay, you're gonna sketch this one. This is our phase portrait. Okay, why in the question it's the reflection of mine? This one is reflection of mine. What did I do wrong? I don't know. So this is x against t. Yeah, this is the function. So maybe t. Did I make a? Where did I make a mistake? It's t gets bigger, and x values. Let's look at our table again. X values goes to minus, right? Plus, then it goes to minus. Maybe I should put minus in front. Anyway, okay, this is the general idea. I don't know, maybe I made a mistake somewhere here, but this is how you see the graph. Okay, like that. And now this is the phase portrait with technology, guys. Now this is a graph against t. Phase portrait y against t. Phase portrait y against t. And it goes like that. This is y. I think they made a mistake, guys, because look, here this should be y. The other one should be x. Look at the same graph we saw, right? This graph and our calculator graph, let me show you, is the same. So this is y, as you see here, it's y, right? T. I think they made a mistake here. It should be the other way around. Y graph is this one, x graph is the other one. But you got the idea. This is how you can find the phase portrait by technology. Okay. And do we have anything else? So this was the phase portrait. You can look at some questions here just to practice.